All right, good morning, everybody. We're ready to officially kick off our 2023 Unidata Users Workshop. And so welcome again. Hopefully everyone has had a chance to get connected to the various things. Again, here, if you're in the room, we ask that you do log on to the Zoom so that then when we get to any Q&A portions, that you're able to use the raise hand feature there for us as well. More on question stuff that when we get there at the end of this first talk. But today, I just want to give a little intro here to our first day's theme before we get to our first speaker here. So the Unidata Users Workshop title is Storytelling with Earth System Science Data, Challenges, Opportunities for Effective, Ethical, and Reproducible Science. And so today, to kick us off, we're going to be thinking about the grand challenges that we all face as scientists in telling our story using the data that we have. And then we're going to move on to some exploratory data analysis piece of getting into data, and then starting to work on a take-home project so that we can actually then use the things that we learn throughout our workshop to then impact our work after as well. And so to get us started off this morning, we're going to have Dr. Russ Shumacher from Colorado State University open us up with talking about this idea of the grand challenge of storytelling with our weather climate data. So welcome, Russ.
All right, good morning, everybody. Thanks for the intro, Kevin. Happy to be here. Good to see everybody here in person. And I love this theme of the meeting. And so I'm going to try to kick things off a little bit with, I guess, kind of telling a bit of my own stories or how my own story, relates to the storytelling theme that we have here. And I'll introduce myself a little bit more and some of my work as we go through here. Are we good on the Zoom? It's working online? Okay, good. Great. So, as we think about this theme of storytelling, and I think you'll probably see things like this as we go through the week. Probably you've seen something like this from an elementary, middle school writing class or English class or something like that, right? The story pyramid that was developed apparently by a writer named Freytag back in the 1800s, kind of synthesizing how stories or good effective stories usually go, right? And so it's this pyramid that starts with exposition, where you kind of set the stage with the normal life or introduce the characters or the situation. And then there's some inciting event, right? And that's where things kick off. And then there's the rising action, some struggle, you reach some climax, and then there's, conflict along the way and maybe near failure. And then you get to the end. It's either a story of victory or a tragedy where all the, Hamlet or something, where all the characters die at the end. But hopefully we get to the victory stage in here, and then there's the resolution at the end. So we'll talk a little bit about, I'll kind of try to weave this through, but I think you're probably all familiar with this idea from reading, or even if you haven't seen it, put forth in quite this way. So we'll talk about this a little bit in the context of our, my own science and career, but also just generally of our data that we use in our field. So to kind of give a little bit of background, going back to when I was a PhD student a number of years ago, I got into, I was kind of interested in data, certainly in different types of data. And so what my pathway was at that point was basically to figure out how to use enough of each programming language that could do the thing that I wanted, but there was not one that could do all of the things. And so I was just looking back at some of the figures from my dissertation. So this was a two-panel figure that had one part in grads and another part in GenPack, because it was hard to get the radar data into grads, but then grads was great for other things. So some of these, you see some very, by today's standards, I think would be kind of hacky figures. IDL was what I started with, so that was where I kind of learned to program and did some things there. But again, it couldn't do everything. These maps are NCL, and I learned how to do some web stuff along the way, but I'm far from an expert in that. Even dabbled a little bit in Viz5D. All right, so some of you probably have used Viz5D. I'm not sure if you can even run it anymore on modern computers, but in any case, it was pretty cool for 3D visualizations, but now we have stuff like Vapor for that. And then this program RIP4 that is good for WRF model, or it started with MM5 model output, but WRF model output as well. So I got to use, figure out how to do enough of what I needed to do in each of these, but not, there was not kind of this ecosystem that we have today that Unidata really has supported, and we'll look at that. So then I did get involved in Unidata Activities, and so I'm happy to be back here at the Users Workshop. So I was on the Users Committee from 2012 to 2015, and then I was the chair before Kevin from 2015 to 2018. And that was where I learned a ton of stuff from all the Unidata staff, from the other university committee members, and committee members from other organizations and agencies as well. And so I think this kind of led me on a nice path that we'll go through in the story as we go here. But with the help of Unidata, we got a weather lab sort of up and running at CSU, a map wall, which we didn't really have up to that point. Now everything broke over the pandemic, and we're still trying to get these monitors and the computer talking to each other again. But for a while, we were having nice weather discussions of folks coming and chatting about the weather. And that was partially supported by a Unidata equipment grant at the time. And then when I was a member of the Users Committee and kind of involved in that, the big thing that was that everyone was starting to talk about was these IPython notebooks, right? So this is I just found this screenshot on the web. So this was the up and coming tech. Python, I think was getting well established, but how do we use it? What are some ways to both analyze the data, but kind of get into this mode of incorporating it into open science, into distributing it on the web and things like that. So it took me a while to kind of get to see the light, I guess, of all the things that the Unidata staff were pushing at the time, and that's probably a similar story for a lot of us, right? And this is why Unidata is here, is kind of push things forward and find hopefully the things that the community will then accept down the line. But there's no way that all of us in the academic world are going to be able to keep up with every trend, and that's why we have experts in this area to do this. And I think that's where Unidata has been really successful over time. All right, so we'll come back to the story pyramid here just to get you reoriented with it. So maybe we're like going up the hill now in the action. So I'm going to focus on just a couple of topics that I and my people I work with work on that I think fit this theme pretty well, and just give some examples from that. So one is more on with my research hat, working with my research group on applying machine learning methods to make weather predictions, or post-process weather predictions to hopefully get better probabilistic forecasts. And this is an older graphic from my former PhD student Greg Herman that really developed all this system, but kind of showing the pipeline here of taking historical forecasts and then predictors that might be weather variables, and then at different model initializations, and then seeing, was there, in this case, heavy rainfall on these different days, and then maybe you do some additional post-processing. You could do some dimension reduction with principal components, but then the workhorse of our system is random forests, and then the output is some map of the probability of excessive rainfall or severe weather or whatever the case might be. We'll come back to this a little bit later on, but I just kind of wanted to set this up. But then where the rubber meets the road with things like this, for example, you're developing new forecasting tools. It's in these testbed experiments, and so this is where you get to hopefully go and tell the story of whatever your new tool is, and get other people excited about it, and find where it works and where it doesn't. So this picture was back pre-COVID, when it was in-person test beds, but you can see, these are forecasters and and model developers and other researchers looking at these forecasts and pointing out where they're good and where they're bad. And so that's kind of a key part of the process here. So that's one aspect that we'll weave through a little bit here. But then the second piece is, are we doing okay with the monitor here? All right. Well, we'll just keep pressing on. Seems to be working well enough. So then the other hat I wear is as the state climatologist for Colorado and director of our state climate office. And so this is kind of taking things in a different direction. And so much of what we do revolves around storytelling with data. And so this is our team, the Colorado Climate Center. And we talk about our mission as threefold. All right. Coming to get some. Okay. Okay. Well, I'll pick back up from here. Yeah, we'll see where we're at in the story here. This is a picture of our team at the Colorado Climate Center, and so we talk about our mission as being threefold. So climate monitoring, keeping track of what's happening here in Colorado, and issues related to well, that's not a big deal. The laser pointer doesn't work anymore, but that's the least of our concerns. So climate monitoring, collecting data, analyzing it, archiving it, keeping track of what's happening, climate research on issues related that are relevant here in Colorado, and then climate services, so which is a wide range of things, including providing data, context, expertise, lots and lots of presentations to varying audiences, outreach, you name it. And so I'm going to talk a little bit about that because in my mind, what we do in climate services is really storytelling with data. That is a place where that really happens and is in this world of climate services, which is new to me over the last few years since stepping into this role. But it provides so many opportunities that I think will be of interest, hopefully, to this group. And so we try to do this some on our website, and I'll highlight just a few things there, but also some of the messages, I guess, that we try to convey to these wide range of audiences. That includes, and I think it's an interesting sort of set of audiences to be engaging with. So it is other scientists to some respect, but not as much as it would be when you're publishing a journal article or something like that. Everything to the general public that doesn't really think about weather and climate at all in their daily life, and then a lot of folks in the middle where it is an important part of what they do, but it's not what they're thinking about all the time, like we are in our field. So this is one of my favorite ones that I think is good for storytelling about Colorado's climate, and the map is kind of it's like abstract art, sort of, right? But what it shows is the color shading is which month is the wettest month on average in each location from a gridded data set across Colorado. And so we're the only state that has all 12 months represented somewhere here on the map. And so you can see, where we are here on the Front Range, Fort Collins, Boulder, Denver, May is the wettest month on average. There's a pocket in the northeast corner where it's June. Most of southeast Colorado is in the summer monsoon season, July or August. You get to the lower elevations on the west slope, it's mostly the fall. A lot of April at the lower elevations and some of the high elevations northwest. And then the high elevation mountains, it's mostly a winter month. There's only a couple little pockets of November there. That's one of the ones that's hardest to find. But still, it's we're the only state that can claim this, and it's a good way to represent, I think, how diverse our climate is in Colorado, between the mountains and the plains and the west slope and the east slope. And it's a way to take a data set and hopefully make it interesting in a way that that you wouldn't otherwise find. This is an example that Becky Bollinger, the assistant state climatologist, put together, where it's interactive, just of the normals, the climate normals for Colorado at the different stations. It's interactive. You go, mouse over a station in your location. You can have it colored by month, and then it brings up a series of graphs that are the normals for that location. So this information's easy. It's not hard to find. It's public data, but we've tried to put it together in a way that just in a couple clicks you can get to what you're looking for without having to dig deep into the way into some website, or grab the data yourself and make those plots. We've been revising the state climate change report here over the last couple of months, I guess over the last year or so, and trying to come up with relevant ways to visualize that. So this is an example, and again, this is interactive if you're on the website, and what it shows is for each month of the year, so January on the top and so forth going down, where it highlights the top 10 warmest and coldest of those months, going in NOAA's gridded data set going back to the late 1800s. And so you can see here through most of the 20th century, there's a smattering of red and blue rectangles on there, but as you get into the 21st century, there's a lot more red ones than blue ones, right? The blue ones don't go away. We still have some extreme cold, but the extreme heat far outweighs the extreme cold. And then, interactively on the website, you can mouse over any of those. It'll tell you which year it is and where it ranked and things like that. So these are all visualizations that are now not that hard to put together with the tools that are available. This one was, I think is useful for some of our climate services reasons, but I was also just kind of interested in it. So interactive maps and graphs of the severe weather climatology in Colorado, where the severe weather reports are, when they happen, and things like that we can now refer back to and point people to when they're asking about where do tornadoes happen in Colorado and things like that. This has been an interesting project, which I think, again, gets to this sort of storytelling theme. We've worked for the last several years with the Colorado wine industry. So you may not know that, especially in Western Colorado, there's a pretty a growing wine grape industry and winemaking industry. So in the valleys around Grand Junction, Palisade, in that area, it's kind of a local warm spot, and you can see that on the map here. So what the map shows is the number from gridded weather climate data, the number of events per decade where it's either extremely cold in the late fall or extremely cold in the winter, so below minus 22 C was the threshold that we used in working with the grape growers of kind of where these are events that the grapes will be severely damaged if these happen, or a hard freeze after bud break in the spring, or a hard freeze like in the early to mid fall before harvest. And so you can see here where you see the purples on the map, these are all places where this happens all the time, and you would not want to try and grow grapes there. But in the yellows, that's where one of these injury or killing events would maybe only happen 0 or 1 or 2 times per decade, and might be worth checking into. And so you can really see where those valleys are, where already grapes are being grown. But if you go down to far southwest Colorado, that's an area where the industry is growing. Of course, this is only climate data, so you also, if I'm not an expert in wine by any means, but you need good soil and all these things too, so it's not the only factor. But it's probably a good starting point, right? Like if you're in a place where you see the purple here, that's not a good idea to even try. But the places where you see the brighter colors, maybe it is worth exploring. So these are some of the kinds of things that where we get to dive into the data and analyze it in interesting ways to hopefully answer questions that people are interested in. This is a visualization that we developed that I really like, that I think is and some of our audiences like it because it's you get a lot of information in a single visualization, and it could actually be even more information depending on how you construct it. But this was so in August of 2020. This was when we had the huge wildfires, biggest wildfires in state history, broke out. And in this graphic, what we see is, so along the x-axis is precipitation, the y-axis is temperature. So the upper left is the drought quadrant, the warm and dry. The upper right is warm and wet. cool and dry in the lower left, cool and wet in the lower right, and then all the years shown there. And then, so this is for Western Colorado, just as an example. This is August of 2020, but the visualization's easy to do for any time period once you kind of have it set up. And you see 2020 there, way up in the upper left, way warmer and near record dry for that August, which is one piece of the puzzle to what set the stage for this record wildfire season that fall. And so I think this visualization helps because you see how far it stands out away from any of the other data points, the past years on there. But then the interesting thing when it comes to using visualizations like this for storytelling is that the scientists will always say, why don't you color the dots by year? Because you already have the temperature information there, that right now they're shaded by the temperature, which I think for other scientists is right, but I sort of feel like for the general public audience, having this look with splotchy, I mean, yes, you do see the more of the warmer years are towards the top, or more recent, more of the warmer years are more recent, but then it's just kind of a mess of colors, and I feel like for the sort of public audience, having this symmetry is more helpful. But it's a decision that you have to make when you're trying to tell your story is, do I want to get the absolute most information into this graph that I can? Because sometimes you do, depending on the audience. But you may also trade some of the information for having it be aesthetically pleasing and still having a lot of information in there. So these are things that you'll get to I think you're already probably working with or will as you look at this going forward. And then another thing we developed for our state climate report, which I thought was it ended up being kind of a cool application because it's basically end-to-end all in Python, was applying cluster analysis to the gridded data, and then so it's hierarchical cluster analysis, but you could, if you're familiar with any of these packages in Python, you can choose different methods and so forth. And so we ended up developing these alternate climate divisions for Colorado, because if you look at this one here, we currently have 5 official climate divisions, with Western Colorado being all of one, and that is not actually all that representative. And so that was one of the motivations for doing this. And so then, once you set up something like this, then it's not too hard to make other visualizations of, for example, temperature change over the time period for those climate divisions, or precipitation change for these divisions, and makes it where you can maybe highlight the things that in a way that's a little more representative than just at the local scale or the county scale where you might normally look at the data, but more localized than if we had these giant regions in there. And then lastly, right now it's nice and green here in Boulder and along the Front Range, but that's not been the case so much over the last few years. And so we can use data to tell stories about the drought conditions. And this is one that I like to use in giving presentations. So this is sort of showing longer term droughts, and this is precipitation only. This is the standardized precipitation index across Colorado. The green areas are longer term wet periods. The brown is longer term dry periods. So you see some of these historical droughts of the Dust Bowl in the 30s and the 1950s, and then the droughts that we've had more recently, and also that the 80s and 90s were a really wet period here in Colorado. But if you keep an eye on the right side of this graph, what I'm going to do is shift it to a different index that also includes evaporative demand, so the thirst of the air for water. So it includes both, so it's SPEI, Standardized Precipitation Evapotranspiration Index, that includes the effects of warming and temperature variability. And so if you kind of keep your eye on the right side, here's SPI, precip only. Here's SPEI, precipitation and temperature. And so if we flip back and forth between those, right, we see this period since 2000 or so goes from, dry, wet, dry to pretty persistently dry through that whole period. And this has then led to many of the water challenges that have gotten huge attention here in the West. And, we'll see what happens going forward, right? Probably we will not continue to be have a lack of precipitation for such a long period. We'll probably go back into, maybe this is the start of a rainy and snowy period here, but the influence of temperature change is gonna play a role there as well. And we can also visualize these, other things, climate projections in a similar way. And this is an interesting story that we kind of developed for this climate report that I think we hadn't really fully appreciated previously. Essentially, that and it may be hard to see the numbers on here, but on the left graph, which is changes in heat waves projected from climate models, the y-axis goes up to 150. On the right, it only goes up to 20 for cold waves. So essentially, the theme, at least from these climate model projections, is that heat waves are going to get incredibly more frequent, or like what we currently consider a heat wave will be happening very frequently as we get to mid and late century. But the changes in cold waves are actually really small. So we have more and more periods of really hot weather in the summer, and maybe expansion of when the hot weather occurs. But then the coldest parts of the year are still going to be just as cold as they were in the past, or maybe only slightly less frequent. So this is, and if you're thinking about agriculture or whatever, this is an interesting thing. All right, so I'm going to bring it back then to research here for the last little piece. One is, I just wanted to show this graph because at that time I got retweeted by Matplotlib, their Twitter account, which they retweet everybody. This is not really that great of an achievement, but I was pretty proud of it because just a few years earlier, I knew very, very little Python, and through the tools made available from Unidata and just kind of spending time with it, I've gotten fairly good at it. And I think you all can too. That's the point of why you're here, is that you can. I did not have some natural aptitude for Python or been doing it for decades or anything. You can start at that point where you only know a little bit of it, and then with some of these tools, you can get good at it pretty quickly and start doing good things. All right, so I'm going to touch lastly just on our machine learning products here, not getting into the science all that much, more just of kind of what we're doing. If you're interested in the forecasts and things like that, you can check out some of our papers on this. But basically, we're using machine learning to try and produce these probabilistic hazard forecasts. And so one of the things that we've tried to do, both to kind of just understand how the systems work, but also to hopefully increase confidence among the users of these tools, which is the national forecast centers, is look at where did it succeed, where did it not do so well. So this is one of our big success cases. This is the severe weather outbreak from mid-December of 2021. So this is a really unusual severe weather outbreak in the upper Midwest in the middle of December, when you don't usually get severe weather up in that area. So this was the operational day 3 SPC Outlook for this event. And this is what our machine learning tool looked like at that same time in that issuance. So very different, right? The SPC Outlook is showing less than 5% probabilities, all areas. Ours has this big area of 30% up in the upper Midwest. And what ended up happening, it was a big severe weather outbreak, tornadoes, lots and lots of severe winds. And so this was a case where our system succeeded really well. So this was a home run for us. And the SPC, so this is Andrew Lyons, one of the SPC forecasters, pointed out that this was good, and they were using it. And so this is big, big confidence for us there. But it is not always so good. So this is just a couple weeks later, sort of a similar situation where SPC Outlook had nothing. Our system had a pretty big area, and what happened in this case, basically nothing. So this was a bad one here. So this is, I think these kinds of analyses are going to be important. And as we look at machine learning tools as part of the workshop here this week, we got experts presenting on explainable AI. This is where things are going to have to go as we continue to use these tools. We're already seeing, not in the weather world so much, but in the general public, right? Like ChatGPT came out, this huge influx, and now all of a sudden is, wow, this is not, we need to figure out some things and not take this all the way to the end right at the beginning. And at least a place where we can do that with what we do is in explainable AI. So we've started messing around with some of these tools where we can dive into what the machine learning algorithm is telling us, not just in aggregate, but on a particular day. And so this, if you do severe weather at all, you're interested in the ingredients-based methodology, right? Like, do we have the ingredients for severe storms? And we're trying to do that with pull that out of the machine learning information. So in this example, you see these maps here. It's basically where, in this case, where CAPE is contributing to the higher or lower probabilities in the machine learning outlook. And then you could loop this over the whole day, and so you could see when in the diurnal cycle, where in space is in this case CAPE contributing to the higher or lower probabilities, and the idea being that a forecaster could do this in the same way that we're used to interacting with numerical weather prediction model output, right? Like you go and you look at, if you're looking at the whatever model, the HER or whatever, you go and you look at the CAPE and you look at the shear. The hope is that we could do this in combination with the machine learning there. So this is stuff that I think is going to be increasingly important, both to build trust in these kinds of tools, but also to just make them better as well. So we'll come back to the pyramid here to wrap up, right? And so we get to the end, and hopefully at the end of this week, you will declare victory over your data, right? And that's kind of the goal of why we're here. And hopefully you don't look like this, that the person crumpled over at the end. And so that's hopefully where we get to is you have some data set you want to work with, and you get to that point of achieving victory by the end of the week. So just a few closing thoughts here to wrap up on this topic. I think, as this is the whole point of why we're all here this week, is because storytelling is fully entwined with earth science, and if we can do this successfully, it really advances our science beyond what we just get from the numbers and the observations or the models or whatever. But we have to be careful too, right? The kind of old thing in journalism, right, is never let the facts get in the way of a good story. We can't do that in what we do, right? We have to be grounded in the data and make sure that the stories are true, at least to the best we can do that. I think it's important, if we're doing storytelling, right, is find your audience. If you don't have an audience for what you're doing, then you're not going to have a big impact. But there are audiences out there for what we all do, whether it's climate services like we do in the State Climate Office, or writing journal articles, or broadcast meteorology, whatever it is. Like, people are interested in this stuff, and if we do a good job of it, I think we advance our science. We make great societal impacts by reducing risk from hazards, or whatever the case might be. I think kind of parallel to this idea of storytelling, right, is the idea of open science, is that all this stuff becomes a lot easier to do and a lot more relevant if we're doing it collaboratively, if you can take these tools and just grab them and plug things in and data sets and so forth. And this is what Unidata has enabled for decades and continues to lead the way on. So I think you'll all get a lot out of that this week. So that's, I guess, my wrap up is to get your hands dirty. I mean, maybe literally, but at least figuratively on your laptop, to learn some new tools and skills and share your knowledge with others, and keep asking good questions and telling good stories. So that's all I've got. We made it through. The screen didn't flicker any more times. So thanks, and happy to take questions if we have time here.
In light of our technical difficulties,
Yeah.
I think we're going to forego
Yeah,
questions
that's fine.
right now, but we're going to drop in the chat a way that we can have folks, if you have questions for Russ, a way to capture those that then he'll be able to see and respond not only today, but then throughout the next couple of days. Obviously, if you're here in person, Russ will be around all day, happy to chat with things today for that, but thanks again.
Yeah, and then you get my wife tomorrow, so it's, you can... She won't know the answers to my questions, but I won't know the answers to her questions. So anyway, we get the whole family this week.
So let's thank Russ one more time.